let's talk about liquid crystal displays, LCDs. They started off in our pocket, in our watches, digital watches, our calculators, and now they've got so much better. They're in all our TVs, they're probably in your mobile phone, they are everywhere, you can't get away from them. So how do they work? They're basically layers. First we start with a backlight layer. With a calculator we just use the reflected light, which is why it's so dim. But for modern TVs, we obviously have to have our actual backlight, and we use something similar to those light boxes you might have had in art class. But what we need is a way to block this light flexibly, because of a few million of pixels on a screen. So what we use is a principle of light in physics called wave-particle duality. The idea that light acts like a wave and a particle at the same time. We don't care that it acts like a particle now. What we do care is it acts like a wave. So what's a wave? When you drop a pebble in a pond, waves go out sort of wibbly-wobbly up and down. Light does the same thing, but rather than just going wibbly-wobbly, because it's traveling through free space, it also travels squiggly-wiggly left and right. And what we can use with this are these things. These are called polarizing filters. And these, on a microscopic level, are actually lots of lines parallel to each other, like a picket fence or a prison sort of cell things. And when the wibbly-wobbly vertical light hits it, and this is aligned vertically, so vertical lines going down, the light goes straight through. But when the horizontal light goes through it, it hits these lines and the light is stopped. So when we had a vertical polarizing filter, and then we had a horizontal polarizing filter, the light stops going through. So we can have a few million of these on the display, and then we can stop, and so we can stop the light. So that's what we do. We have one vertically and one horizontally. And so now we've made a light, and we've blocked the light, which isn't that productive. So what we have in the middle, sandwiched between these two, is a liquid crystal. So a crystal is a structure that's shiny and see-through, but it's also highly organized on a microscopic level. So all the molecules are lined up in sort of a grid pattern. And so the light goes through vertically to begin with, then it goes through the grid, and then it hits the horizontal one and stops. But when we apply a voltage to it, because it's liquid, which means the molecules can change under circumstances, the molecules actually twist into a helix, like DNA, and the vertical wibbly-wobbly light twists with the crystal and can now go horizontally through the filter. So this way, we can suddenly get, just with voltage, light turning on and off on this display. If we want color, we just add red, green, and blue filters, and it all mixed together. So, yeah, thank you.